Hey, chemistry kids! Today we're going to review seasons, equinoxes, and solstices. As you're doing this, you're going to follow along with your notes. Feel free to stop the presentation at any time to fill in those notes, and later you'll be taking a test, which is actually an open notes test. So that's my gift to you. Okay, guys, let's get started here. Okay, let's go through some essential questions. What are the relative positions of the Earth and Sun? What are the daily and annual motions of Earth? How does Earth's tilt cause seasons? And what are the differences between solstices and equinoxes? So these are the questions that we're going to be answering today. I know most of you pretty much know these based on the review that we've had in the past couple days, but I just want to reinforce that learning today. Okay, Earth's motions. So two main motions of Earth are rotation, which spins on its axis at a 23.5 degree tilt. Okay, so we are rotating. You can see in this image that the Earth is actually spinning around, and that is the cause for the day and the night. And the next is the revolution, which the Earth moves along and in an elliptical orbit around the sun. And that is displayed down here in the right-hand corner. You can see the Earth is moving around the sun, not as fast as what's being shown, but that's just for simplicity's sake. So please understand that the difference between the rotation is the spinning and the revolution is the travel around the sun. Okay, Earth's daily motions. The time it takes for the Earth to rotate once is called a solar day. So solar day is 24 hours. It's approximately 24 hours. The Earth rotates on its tilted axis eastward. And again, that tilt is 23.5 degrees. The Earth rotates counterclockwise. And this is exactly what causes a change in the daylight hours. Okay, so this is a Foucault pendulum showing the progress of Earth's rotation. As the Earth rotates, the pendulum shifts its orientation. Earth's rotation. Rotation is the cause of day and night. Earth's day can be measured in two ways. A solar day, which is the time interval from noon one day to the next, which takes 24 hours, or this sidereal day, which is the time interval the Earth takes to rotate with respect to a star other than our sun, which is 23 hours, 56 minutes, and 4 seconds. So again, this is one of the reasons why we have a leap year. So I know some of you like to point out that we don't have exactly 24 hours in the day, but this is the true cause for why we have a leap year. So you can take the opportunity to watch this video. I'm going to skip it for now, but you can see an additional copy of the presentation, and you can fill in your notes accordingly. Let's move ahead to Earth's revolution. Earth's revolution is the time it takes for Earth to revolve around the sun. It takes 1 year or 365 days. Every 4 years is a leap year with 366 days, and the Earth revolves around the sun in an elliptical orbit at a speed of 107,000 kilometers per hour. That's just a fun fact. Don't worry, you're not going to be tested on that. Earth's revolution. The path or Earth's orbit is an ellipse, meaning that the distance from the sun varies. So you can see down here, we are not in a perfect circle. It's more of a shape of an egg. Earth is closest to the sun 147 million kilometers away from the sun. It occurs annually on January 3rd, and when Earth is farthest from the sun, that is known as the aphelion. So you can see on the left, the perihelion is when the Earth is closest to the sun, and on the right, we have the aphelion, which is when we are the furthest from the sun. It occurs on July 4th. Okay, so astronomical units is the distance from the Earth to the sun. We are about 93 million miles or 1 astronomical unit away from the sun. Astronomical units are used to measure the distance in our solar system. So again, 1 astronomical unit is 93 million miles. Guys, I want you to take in this picture and really try to understand Earth's tilt and how day and night occur, and then at the same time, understanding the seasons. So Earth's tilt and sunlight, so the amount of sunlight an area receives depends on the Earth's tilt relative to the sun. So looking at this image, the northern hemisphere, which is all of that land that's above the equator, and you can see the equator left, but we're tilted, so it's right here. It runs through the center of the Earth. And the area north of that is the northern hemisphere. We are currently experiencing summer in the northern hemisphere. And the southern hemisphere, which is all the area south of the equator, is experiencing winter. Now notice over here, this looks like this area that is lit up in the northern hemisphere. Obviously, this is day because it's all sunshine. So the north and south on the right-hand side are experiencing daylight, and on the left, because it's dark, obviously we're experiencing nighttime. Earth has seasons because its axis is tilted. So again, the reason for the seasons is solely due to the fact that Earth is on its axis. Now think about it. If Earth was straight up and down and did not even have a tilt, we would have exactly 12 hours a day, 12 hours a night, and that would never really change. So, but because we're tilted, we have varying hours of daylight and nighttime, which affects, the amount of sunlight that's actually being received at that particular time. So whether our Earth is warm or not in that particular season. Earth's axis and seasons. The 23.5 degree tilt of the Earth's axis is the reason for the seasons. The hemisphere that receives the most direct sunlight experiences summer. The northern hemisphere experiences winter during perihelion and summer during aphelion. So you don't have to worry about these words, guys, but I just want you to understand where winter and summer are occurring in the northern hemisphere. And the southern hemisphere experiences opposite seasons of the northern hemisphere. So again, when we're having winter here in Texas, down in Australia, they're having summer. Looking at this image here, we can try to predict exactly what seasons the northern and southern hemispheres are experiencing. So in December, the sun shines directly on the southern hemisphere. So if you're looking at the top, you'll see that the southern hemisphere is receiving more of the rays. Therefore, it's summer in the southern hemisphere and winter in the northern hemisphere. After we have winter, we are going to be heading into spring. So if you look at the second picture down, the sun shines equally in the northern hemisphere as it does in the south, and the north is experiencing spring and the south is experiencing fall. Moving on to the third picture, it's now June. The sun shines directly on the northern hemisphere and indirectly on the southern hemisphere. What season is south of the equator? So what season would be south of the equator? Obviously, that would be winter if we are having summer in the northern hemisphere because we have opposites. Then in September, the sun again shines equally on the northern hemisphere and southern hemisphere. The north is experiencing fall and the south is experiencing spring. Earth's tilt and seasons. Take in this picture, guys. Try to understand exactly when these seasons are occurring. You will be asked on your exam to label and identify different seasons in different hemispheres. Texas is the northern hemisphere. A country like South America and Australia are going to be in the southern hemisphere. And if for any way you're confused, you can always look at the diagrams and look at the pole. We have the North Pole at the top and the South Pole at the bottom. Again, this is another video that you can watch on your own by clicking on the presentation itself, the additional copy that I have provided in Schoology. So equinoxes and solstices mark the beginning of each season. So again, guys, you can take a look. Remember, I've talked about the North Pole in the winter months as being in complete darkness. So you can see over here on the left, we are in complete darkness in the North Pole. So obviously the northern hemisphere must be in winter. And if you look over on the right, you can see the North Pole is in complete sunlight. So obviously that must be summer. And again, you can see that the northern hemisphere is lit up more. So obviously we have more direct rays coming from the sun into Earth, warming the planet. Equinox happens twice a year. The Earth experiences an equinox. Equinox is derived from two Latin words, meaning equal and night. And during an equinox, the Earth's axis is neither toward or away from the sun, resulting in nearly equal amounts of daylight and darkness at all latitudes. What does that mean? That we have 12 hours of day and 12 hours of night. So this is what the Earth looks like during equinox. You can see that the rays are even, and they are coming into the Earth pretty much at the same percentage. Again, here are vernal and autumnal equinoxes. This is when we have 12 hours of day and night. Again, spring and fall. We also have a summer solstice when we have the longest day of the year in June, and we have a winter solstice when we have the shortest day of the year, and that is in December. Again, one more additional video for you to take in. I highly recommend that you watch these videos. They're very educational, and they really, really help you understand what is being instructed. Okay, solstice. Okay, winter solstice above. The southern hemisphere is experiencing summer, while the northern hemisphere is experiencing winter. Twice a year, the Earth experiences a solstice. It occurs when the Earth's tilt towards the sun is at its maximum. And it's the longest day of the year during the summer solstice, and the shortest day of the year occurs during the winter solstice. And again, here's the picture just reinforcing the summer and winter solstice. Looking at this picture, you can now see that the southern hemisphere is experiencing summer and the northern hemisphere is experiencing winter. And again, if you were to just look at the rays that are coming in and the amount of light, here is the equator right here coming down the center of the planet. And we have more area that is lit up by the sun than in the northern hemisphere. There's just this tiny little pie wedge, whereas down here, we have a larger surface area that's being covered by the sun's rays, therefore warming the southern hemisphere, making it summer. Here's an additional video for you to take in. And finally, if you choose, you can play Kahoot and see what your knowledge is like after this review, and then if you're confident enough to take the exam. Okay, guys, if you have any questions, I'm certainly available for those. Good luck on your exam. You can use your notes. If you do have questions, I'm always here to answer them for you. Good luck on your test, and I will see you guys soon. Bye-bye.